Good evening, everyone. We're back once again with another amazing science tutorial video. I'm Coach Spivey, and before we begin, I want to give a shout out to my entire third period class. So shout out to Jalarian Reese, Andre Griffin, Denzel Jones, Tori Finney, Taquarius Solomon, Jamon Jackson, Jacoby Hollenshed, Christian Finney, Carmen Patterson, Savon Evans, Eric Bowden, Moesha Williams, Miracle Woodford, Jarnice Johnson, Naira Darby, Amia Carter, Deontay Watts, and Adina Marsh. I got a great group of kids, and this is the reason why I do what I do. So let's go ahead and get started on this speed and velocity video. So first things first, what is motion? Motion is a change of position of an object with respect to time. So if you notice, the skateboarders started off in one place and then they ended up in another place. So changing their position with respect to time. And then what is a frame of reference? A frame of reference is the reference or the starting point. This is basically the point from which the object is moving or starting from. So for example, this person starts at the start line and unfortunately they don't get much further past that. But the frame of reference is the start line at this track meet. Next, we take a look at a distance, and distance measures how far it is between two objects and or how far an object has moved. So for example, if we look from Macon to Atlanta, it is approximately 84 miles. So we go from Macon to Atlanta, this is 84 miles. That's the total distance. And then we take a look, going from Macon to Savannah, that would be approximately 166 miles. So this is how far an object or how far you have traveled from one place to another. That would be your distance. And then displacement is a change of an object's position. So the question is, how far are you from your original starting point? So this also includes a direction. And for example, we have north, south, east, west, away from, or towards. And our displacement can actually be less than our actual distance. So we'll show you that in the next slide. So let's take a look at distance versus displacement. And in our example, a man moves from point A to point B, then to point C, and then finally to point D as shown in the opposite in this diagram right here. And then we're going to find the distance and displacement traveled by the man. We'll notice he travels a distance of 50 meters from A to B, then another 30 meters from B to C, and then another 50 meters from C to D. So all we have to do is add up our distance. So 50 plus 30 is going to give us 80, and then 80 plus 50 is going to give us 130. So the man traveled a total distance of 130 meters. Now let's take a look at our displacement. So the man started here. This was his start point or his frame of reference, and then he actually ended up here at point D. But if we notice, he's actually only 30 meters. He's actually only 30 meters away from his starting point. So if you notice the difference between distance and displacement, distance asks the question, what is the total distance this person traveled? And it shows it right here, 130 meters. And displacement asks, how far is the person from their original starting point? So the man is actually only 30 meters away from his original starting point. So that's the difference between distance and displacement. So now let's take a look at our first check for understanding. You're going to write the correct vocabulary word by each description. And your vocabulary words are frame of reference, motion, distance, and displacement. You have 1 minute to fill in the following blanks, and we'll begin that 1 minute starting now. Go ahead and pause the video. So now let's see how you did on your first check for understanding. Number one, Jamon traveled close to 900 miles to get to Dallas, Texas. So 900 miles is talking about the amount of distance he traveled. So number one would be distance. Number two, Deontay started at home and drove to Northeast High School. So his start place was home. So his frame of reference would be home. So number two is our frame of reference. Number three, Adina is at least 15 miles from home. So home is always where we want to start it, but how far is she from home? Adina is at least 15 miles from home, so that's talking about her displacement. And then number four, Cornelius threw the football. And since the football is moving, the football is in motion. So remember, motion is a change in an object's position with respect to time. So now let's take a look at speed versus velocity. Speed is how fast an object moves in a certain amount of time. So for example, the car is going 35 miles per hour. And that means that for every hour that car is traveling 35 miles. And then if we look at velocity, velocity is how fast and the direction an object moves in a certain amount of time. So let's look at our key differences between speed and velocity. Speed talks about how fast, but velocity talks about how fast and the direction. So that's a big difference. Speed only talks about how fast, but velocity talks about how fast and the direction. And velocity also always includes a reference point or a starting point. And then the direction is also referred to as a vector. So direction is a vector quantity. And then so example, the car is going 35 miles per hour north from Walmart to Northeast High School. 35 miles per hour is talking about how fast, and then the direction is north. And our reference point or our starting point is we're starting from Walmart. There are three types of speed. First, let's start off with constant speed, which constant speed is a speed at a constant rate. So for example, 65 miles per hour for 1 hour. So if you're on the interstate with your mom or dad and they set the car on cruise control, they're setting the car for a constant speed. And then we take a look at average speed, which is the distance traveled over the total time to travel that distance. So for example, the distance from school to home over how long it takes to get there. And then we have instantaneous speed. This is how fast you're going or something is going at a certain time. So for example, traveling right now at 70 miles per hour. So this right here, this picture right here is showing a police officer holding what we call a radar gun. And what a radar gun is designed to do is calculate or determine a person's speed at a certain point of time. Now let's take a look at our speed, aka velocity equation. So our formula is V equals D over T, and you can also see it as S equals D over T. They mean the same thing. Velocity equals distance over time, or speed equals distance over time. And you use both to solve for velocity or speed. And then if you look right here to the right, here's our velocity and speed triangle. So for example, if we wanted to solve for distance, we would put our finger over the D and that would leave us with speed times time, like shown over here. Say if we want to solve for time, we would put our finger over T and that would show us distance divided by speed. And then if we want to solve for speed or velocity, we put our finger over the S and that would show us distance divided by time. So V equals speed or velocity, so the unit would be V, and then our unit D stands for distance, and the units can be meters for M, or we can have miles, or we can have kilometers, which would be shown as km. And then our unit would be time. T stands for time. Then our units can be seconds or S, or hour, which the abbreviation would be HR. And then our unit for velocity or speed would be meters per second, so M/S, or it could be miles per hour, MPH, or you could see it as kilometers per hour. And then it may be different depending upon the problem, so your units can change, so be careful and make sure you look at your problems very carefully. So now let's take a look at our speed and velocity practice problems, and we'll do these problems together just so you can get a feel for how to complete them.